So now we begin the journey of finding the area under a curve. So first off, we want a function that's specifically continuous. You can draw without lifting your pen. Non-negative, that just means it's above the x-axis between a and b. Doesn't seem so profound right now, but it's a big deal. And there we go. So I want to find the area between those two x values. So we're going to divide that region between a and b into n equal, I'll call them subintervals, but they're really rectangles. Okay, so let's look at what we've got here. So if I'm looking at the graph of y equal x squared, so I'll just draw it here. And I'm looking between 0 and 1, so I'm going to be generous and make 1 here. And I want 4 equal rectangles. Okay, so that means the delta x is going to be 1 minus 0 divided by 4, or 1/4. So that means each rectangle is width 1/4. So here's 1/4, here's 1/2, here's 3/4. Okay, so then our first rectangle will be from here to here. So I'll just call that rectangle number 1. And I'm going to use right-hand endpoints. So I'm going to go up to that y value to make the rectangle. So it's actually bigger than the area under the curve. So let me take advantage of colors here. So rectangle 2, I'm going to go to this right-hand endpoint. I'm going to make that rectangle. So that's rectangle 2. So what we're going to be doing is we're going to be finding the areas of those rectangles. So area of rectangle 1, the green one, will be 1/4, that's the width, times the height, which is f of 1/4. Area of the blue one, again, width of 1/4, and then the height will be f of 1/2, that height right there. So let's move on to the third rectangle. The third rectangle again has width 1/4, and we're going to go up to the height of 3/4. So that's the y value we use. And then the very last one, the width is still 1/4, and we're going to go up to f of 1. So not a great picture, but that's the idea. So this number will be bigger than the area under the curve, right? Because you can see all this extra region. Okay, so let's do it again. Let's do it. So we choose the left-hand endpoints. So let me draw the curve again. And again, it's really useful to draw the numbers hugely apart from each other. And subintervals means your delta x is your b minus the a over the n. So again, 1/4. So 1/4, 1/2, 3/4, right? And what we're going to do is we're going to make rectangle number 1. And if we use the left-hand endpoint, so here's left hand, here's right hand. Wait a minute, I've got no rectangle. Yep, that's right. Okay, so let's move on to the second one. So the second one, second rectangle here, I use the left-hand endpoint, so I get something like that. So it's the width of 1/4, f of 1/4, so it goes up to that height, so that area gets counted by that color. Then the third rectangle, I go up to here, so 1/4 width, f of 1/2, that gives me the area of that rectangle. And then finally, rectangle number 4, 1/4 is the width and height of f of 3/4. So that gives us less than the exact area under the curve. Okay, we're moving towards the exact area of the curve. We're not there yet. Oh, what if I did midpoints? Okay, so I'm not going to draw it really big. So here's 1/4, 1/2, 3/4, and 1. And so if I'm doing midpoints between this and this, right, then I'm going to be choosing the x value of 1/8. And that's what I'll make my rectangle look like, right? So there's 1/8. So let me erase that so you can see. So, I didn't mean to do all of that. Okay, so here, So this x value here is 1/8. So that's the y value I use. So that's what this is, the width of 1/4, and then the height of f of 1/8. Go to the next rectangle. Still width of 1/4. Between 1/4 and 1/2 is 3/8. So I make this rectangle that looks like that. Then the next rectangle, I go here and I'm going to use 5/8, which is in between those two. So the width of 1/4, height of f of 1/8. And then the last rectangle, I'm going to use 7/8. So I go up to the 7/8, partly inside, partly outside. So I didn't figure out the number of this, but this would be in between, right? This number and this number, and then we get here. So we're not going to be satisfied with midpoints or anything like that. We're going to move further, but let's just play with this. So R sub 3 means right-hand endpoints, and then the sub 4 here meant 4 subintervals. So for this one, it means 3 subintervals. So I just want us to practice with this. So the delta x would be 3 minus 0 over 3, right? Because the n is 3, the a is 0, the b is 3. So that means each width is 1. Oh, that's kind of a nice number. All right, so I'm going to draw the function. I think it's helpful just to have the function there. And I know I'm going to make rectangles of width 1. 1, 2, and 3. And so rectangle number 1 here, if I'm using right-hand endpoints, I go to here. Right? So the rectangle R sub 3 will equal the width of 1, right? Because that's what the width of the rectangle is. And then times f of 1 plus. Okay, so let's move to the next rectangle. Get a different color. So rectangle 2 here is going to have the width of 1. And if I'm using right-hand endpoints, I'm getting that f of 2, right? And then plus the third rectangle, I'd use this right-hand endpoint, so I'd have 1, the width, times f of 3. Okay, so what does r of 3 look like? It gives us 1 times root 1, which is 1, 1 times root 2 plus root 3, and that's a fine answer, right? Because these things here means I'm putting the numbers into the original function. All right, so let's go to the next one. So this is L sub 5. L means left-hand endpoints, and n equal 5, right? That's what this means. And so I want to find out what the delta x is. And so this is the A, and this is the B. So I have 5 minus 0 divided by 5. Oh, it's 1 again. I like nice numbers. Okay, so I've got x cubed. So you know it looks something like that. And I'm going to have 1, 2, 3, 4. Oh, I didn't draw it big enough. Hold on. Let me come back to that again. All right, so I'm going to have 1, 2, 3, 4, and 5. Okay. And so it really doesn't matter the graph much, right? Okay, so oops, something like that. Okay, so L sub 5. So for the first rectangle, I use the left-hand endpoint. And that, let me make that graph better because that's not how it looks, is it? All right, so it goes like, there we go. Okay, so left-hand endpoint, oh my goodness, that's 0. So that's going to be 0. I'm just going to put 0. All right, so the second rectangle is right here. Choosing the left-hand endpoint, I'd have the width of 1 times f of 1. And then going to the next rectangle right here. So I would have the plus, the width of 1 times f of 2. And then again, the width of 1 times f of 3. Couple more, right? The width of 1 times f of 4, right? That would give us this one. And then one last one, the width of 1, f of 5, plus 1 times f of 5. Okay, so let me make room up here to be able to finalize the answer. And I'm not going to be concerned about you putting in your calculator. I know you know how to punch numbers in your calculator, so I would love to see it unsimplified. All right, so here we go. So L sub 5 would equal, well, that's 0, so I'm not going to put anything for that, right? That's just gone, 0. 1 times f of 1. Remember, we're plugging it in here. 1. 1 times f of 2. Well, I know 2 cubed is 8, plus 1 times f of 3. I know that 3 cubed is 27, plus 1 times f of 4. I know that 4 cubed is 64, and 1 times f of 5, that's 125. That's a beautiful answer right there. Okay, so last one on this is finding the midpoint on this function between 0 and 6. And this little 3 here means n equals 3. Okay, let's check what that means. Delta x is b minus a over n. So that's 6 minus 0 over 3. Oh, that's 2. Okay, x to the 4th, looks like that, right? Just like a kind of a basic parabola. So my intervals will be 0 to 2 to 4 and to 6, right? So there will be 3 rectangles, right? That's what the n means. There's 3 rectangles. So let's do this. So m sub 3. So the first rectangle will have width of 2. And then I'm going to use f of, and I'm going to use the middle point between 0 and 2. And isn't that 1? So I'd say 2 times f of 1. Plus, okay, again the width of 2, and then I would say f of, and I'm going to go up to that y value, and the x value I'm using is 3. Plus, okay, going to this third rectangle, still the width of 2, and the x value I'd be using would be 5. So I'd have 2, and I put 1 into the function, that's 1, plus 2, put 3 into the function, so I'm just going to say 3 to the 4th, plus 2 times 5 to the 4th. And there we go.